Hello everyone, this is Cody Jackson for Cody. We are continuing our Python journey. Today we are looking at Python functions. If you want to play along at home, these are the books that I'm using. For what it's worth, we are almost halfway through the Learn Programming in Python book. So the first half just covers basic introduction to Python. The second half is more of a capstone project that kind of takes it all together and creates a simulation scenario that combines everything that we've learned as well as some additional stuff, good code practices, things like that. Secret Recipes goes into more advanced stuff that is not commonly used, but it's kind of like good to know type of stuff. So jumping in, using functions. So functions are blocks of code that can be reused within the program simply by calling the name of the function whenever you need to use it, along with whatever arguments are provided to it. If you didn't have a function, you would have to copy and paste that code block multiple times whenever you wanted to use that same functionality. And whenever you update your code, you would need to remember all of those locations where you had that functionality to update those. Whereas if you just have a function, all you have to do is just change the function functionality, maybe the function name, and that's it. Everywhere that function is called is automatically updated with that single change to that function. If you're using a modern IDE, you can not only change the function name, but it will go through and identify all of those locations where that function is being called, giving you the option to either, yes, include that change in functionality, or no, keep the old functionality, or just change the functionality, period. So basically, you kind of have the option of how you want to use that function. You can keep the same function, you can update it, or you can change it across the board or in specific locations. So here's just a brief example. We're actually going to walk through this in an interactive scenario. I just wanted to have this as a slide to explain the primary parts. So def defines the function. At this point, we are defining what that function is, giving it a name. In this term, in this time, the name is squared, and we say that it is taking the argument x. The only thing that is required to define a function is the def key name, whatever name you want to give the function. The parentheses can be empty, and then the colon. Everything that's below that is going to be indented and part of that function. So because the 4x in range is not indented, it's not included as part of the squared function, and so this is basically telling Python that this is a separate block of code to be processed. For this block of code, we're just making a range of numbers, and we are passing those numbers in to the squared function, and then getting the results. So let's jump over to IPython and actually process this and see what actually happens. When we execute our code, we take each of the numbers from 1 to 10. Now remember, the offset starts at 0, does not include the last number, so it's actually 1 to 9. Takes each one of those values within that range, 1 to 9, passes it as the argument to squared, and then returns the value of x times x, so that number times that number. And it goes through from 1 to 9 all the way down, and that's it. That is probably the most basic function that you can have, and it includes everything that you need, even some optional stuff, whereas the argument doesn't have to be there. If you wanted, you could make a simple function. In this case, we are just defining a function called hello, printing a string. That's it. There's no arguments, nothing. When you call that function, it does exactly what your functionality is, which in this case is print a string to the screen. Back to our slides, we're going to talk about how to use Python operators in different ways. So polymorphism is determining what the functionality is being called for a certain data type. Python uses what's called as duck typing. Duck typing just says, based off of what this data object appears to be doing, I will make an assumption of what I should do to it. So, and it goes back to the, if it looks like a duck, quacks like a duck, then it must be a duck. So in Python and a lot of interpreted languages, duck typing is used to determine a variable that doesn't have a static type. What data type is that variable being used as? Is it a string? Is it an integer? Is it just a general object? And so that's what duck typing does. It allows you to use dynamic types within Python, and you don't have to manage assigning a original type or changing that type if you need to later on. So, for example, for the star operator, it can be a multiplication sign if you're using numbers, or it can be a multiplication identity for strings, which doesn't make any sense, so I'll give you an example. For this example, we're using the star operator, and if we give it integers, it knows that with integers, as numbers, you multiply them, and so it multiplies them and gives you the value. For strings, there's no inherent functionality for strings, so it kind of defaults to multiplying strings by themselves, if that makes sense. So we have a string spam, and we're saying *6, so give us spam 6 times. So it basically be saying 1 times 6. But in this case, we're getting spam, 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 spam 6 times as the output. This is called operator overloading or polymorphism. So when you're looking at operators, they can use that dynamic typing to determine what a variable is. So like those integers, while they were integers physically and that we were using numbers, those could have just been variable names. They could have been the variable a and the variable x. And we can define them on the other end as to what we want those to be. In this case, we go back and we say a is 5, x is an integer, and so we're effectively saying 5 times spam. And so it gives us out spam 5 times. So that's one of the reasons why dynamic interpreted languages are a little bit slower for large data values, because it has to go through and determine what the initial value is or what the initial type is for a variable, and then when it's used again, has that variable type changed? Say, for example, you started out with a string of a number, so maybe you have a string of 12, so that's a string value, but later on you want to change that into an integer. And so if you do that at some point in your code, now instead of being a 12 as a string, it's 12 as an integer. And so Python has to figure that out every time that variable is called. Now, there is a thing called type hints where you can tell Python what to expect, and that doesn't necessarily speed things up, but it does help in data validation to confirm that the data that's expected is indeed what you have told it. This is useful in a case of right here where you had a string and you wanted to change it to an integer, but you forgot in the code to change it to an integer. You'll get a warning saying, hey, I expected a string, or I expected an integer, but I received a string. So you have to go back into your code and double check where that code is to make that conversion for you. So before I leave this topic, I just want to talk about the arguments that a function can have. Very often you will see star args and double star KW args. Basically what that means is star arguments, double star keyword arguments. So star args means it's basically a wild card. Any arguments that are passed in are going to be captured as arguments. So you don't have to specify A, B, C, D, or whatever your arguments are. You can just capture all of them and then do some processing with them later. And what that does is it allows you to not have to know how many arguments are coming in. You can have an unlimited number. So for programmatic purposes, meaning you as the developer are not making this decision, but the program is figuring it out dynamically as it runs, you can have anywhere from 0 all the way up to 1,000 arguments coming in, and the function will handle all of those at the same time. The double star keyword arguments does the same thing, except it is taking almost like a dictionary pair, where you have a keyword equal to a value, and that becomes a single keyword argument coming into the function. And so you can basically set up almost like a dictionary, where you have your keywords and a value associated to it, and those are all passed in as arguments to the function, and then the function will go ahead and process those keyword arguments as regular arguments. So we're going to talk very briefly about lambda functions. Lambda functions are also called anonymous functions. Basically, that's because you do not use the def keyword to define the function. It's anonymous in that it doesn't have a name that you can call. It is in line to the rest of your code logic. So it's basically an expression that returns a value in line, but you cannot call it again if you wanted to do it later. So it's easier just to give an example and show you what I'm talking about. So in this example, we have a regular function defined as funct1 with 3 arguments coming in, and then we just return the multiple values of those, whether those are strings, numbers. In this case, we're just calling some integers, and we come back with the sum of those equals 60. We define a lambda function as being equal to a variable name. We call the keyword lambda, which says that we are creating a lambda function, an anonymous function. Our arguments are provided immediately after the lambda, and then we say the return value is going to be whatever is on the other side of the colon. And then we call it the same way we call a regular function, and it works exactly the same way, except that because a lambda function is in line and considered an expression, it can be used in places where normal functions won't work, such as within a list or as an argument into a function, things like that. On the other hand, because it is an expression, and expressions break down to a particular value, whereas a statement in Python performs code logic, and I don't think we ever touched on that. So to reiterate, if you have a statement in Python, it actually does some sort of processing on the other side. An expression doesn't do any of that. It just breaks down to a final value. So a variable name with a value assigned to it is an expression. That variable name becomes a single value. whereas a statement performs some logic. So like if statements in your if-else block is a statement because it does some processing. So back to our example here, this definition of a function is a statement, whereas we are assigning a lambda value to a variable name, and so this is an expression. So touching on that, expressions, because they break down to a single value, there's a limit to what they can do. So if you're going to be working with a lot of code statements such as if-else blocks and things like that, loops, then you really need to define a normal function. You can't get away with a lambda function because you can't put that additional functionality within lambda. It basically has to fit on one line. Lambda functions are sort of popular in third-party libraries. It really kind of depends on what the code is trying to accomplish and whether the developer decided a regular function is more useful than shortening the code and just providing a lambda in there. You can kind of think of lambdas as list comprehensions, where instead of having a full block of for value in this list do something, your list comprehension kind of dumps all of that within the square brackets. Lambda functions are basically doing the same thing. You can see that we have the input arguments, we have the output return, and so we're just kind of shortcutting this entire thing to a single line. But if you want to do anything special, you really need to determine, can I fit it all on one line, or can it all just be within a regular normal function? And finally, you can find some third-party libraries where lambda functions are used as arguments for other functions, for class instantiation, and various other things. So be aware of it. However much you want to use it is up to you. I don't use them very often, but you'll see other people who do like to use them. So, in conclusion, we talked about the purpose of functions, how to use them, how functions are created, looked at polymorphism, where the functionality of operators can change based off the data types. If you want, you can go in and use the built-in tools of the Python language and create your own polymorphed operators. You can do operator overloading on your own if that's something you want to do. I think we talked about that in the exceptions video, where you can take the base exception and make your own exception based off of whatever it is that you want. So like say negative numbers, there's not a default exception for negative numbers, but you can go ahead and make your own negative number. And that's an example of polymorphism, where the base exception does a certain thing and you are overriding that to look expressly at negative numbers. And finally, we reviewed lambda functions and how they can be used to minimize the amount of code that is written, as well as the special circumstances when you have to use lambda functions to get the functionality that you need. Next time, we are going to talk about object-oriented programming, specifically classes, methods, namespaces, instances, all that stuff. So that's actually going to probably be multiple videos because there's a lot to talk about. And after that, we will look at files and databases, and that's basically going to be the first half of that learning Python book in terms of all of the basics that you need. After that, we're going to look at some actual software engineering principles in terms of planning your design structures, and we'll actually start getting our hands dirty later on with actual programming. So stick with this. This stuff might be boring right now. It may be stuff that you already know, but it does serve a purpose as the foundational groundwork for our simulator program that we will be working on in the future. So in the meantime, keep learning, enjoy life, don't get sick. If you have any questions, comments, please let us know in the comments. And until next time, have fun and enjoy yourself. Keep learning. Bye.